From the beautiful studios of Way Happy, this is Mr. Meyer and continuing on with areas between curves. All right, example 4. Find the area of the region of those two graphs, and we get a calculator, so guess what? I'm going to use it. I typed it in, and I zoom 6'd it, and that's what it looks like, and maybe you would appreciate actually seeing it. So zoom 6, there's the first equation, the cubic, that's my y1, and then here comes y2, the parabola, and that's what it looks like. So notice there's two areas that I can find, right? There's this one here on the left, and then there's this one here on the right. So I am, and notice, what do you notice about that is hopefully you notice, maybe if I can, I'll try to draw it here. I will, the cubic, I can't remember, how did that thing look? It was, all right, just a nice little cubic and then a parabola. So it went like this. I should have done two colors. And then the other color, the other parabola, I can't remember, it did something like this, right? Something like that. My areas aren't perfect, but whatever. So this was g of x, and this was f of x up here. Now notice that the red one is on the bottom in this first chunk, right? In the shaded yellow region, the red is on the bottom and the black is on top. In the blue region, the red is on top and the black is on the bottom. So therefore, we're going to have to do this two different ways. All right, and on my calculator, I have f of x is my y1 and g of x is my y2, so that might help me here in the long run. And now that I've labeled it on my graph, at least people know exactly what I'm saying. I could have also done that here. I could have said that this was y1, and I could have said this is y1 and this is y2. Oh, I just noticed something. Oh yeah, I think I got them in there right. I better check my graph real quick. Did I have the minus 10? Yes, I did. All right. Now, what do we have to integrate? Like I said, we have to integrate. Oh, I don't know this position, but I know the black one's on top, or y1 minus y2. I'm going to have to do that. But I don't know from what points. Excuse me. So I'm going to have to go ahead and figure out where those intersections are. Well, that's a piece of cake, right? I just go second, trace 5. First curve, enter. Second curve, enter. It looks like somewhere where x is 2, so I'm going to press 2, enter, and it's going to say it's at 2, 0. That's not the one I wanted. I wanted negative 2, so it's nice to have one at 2, 0. I'm going to go second, trace 5, enter, enter, and I'm going to pick my guess. I said at negative 2 was the one I was actually looking for, which is at negative 2, negative 8, so that's good. At x is negative 2, they do intersect nicely. And then I think the other one looks like it's at 0, so second, trace 5, enter, enter. I think it's at 0. It is at 0. This is easy. It's at negative 2 to 0 and then 0 to 2. So those are my areas, right? So I'm going to go from negative 2 to 0 on this one. And then I have to do from 0 to 2. Now the red one was on top, y2 minus y1. Oh, and I made a big mistake by not closing my bookend, right? Really? Every time. All right, before the great crash, what I was saying is I didn't finish my bookends. I have the integral symbol on one side, but what's supposed to be behind it is dx. And yes, you have to have those bookends on either side of your function. Otherwise, you look like you don't know what you're doing. So there it is. Now they are complete. And now I can go to Sheila and I can have her do this problem. Now, I'm just going to go, what is it, Math 9. Oh, get out of there. I don't want it on graph. I want to go Math 9. There it is. I said it's going from negative 2 to 0. And now the cool part, I can just pull it up either using the vars button, or if you've probably seen me do alpha calc. And we said it was, I think, y1 minus y2. So I will do y1 minus y2, and then with respect to x, and that'll give me the answer is 12. And then if I do the integral one more time, so I was going to copy, but it's probably easier just to do it again. Math 9 from 0 to 2 of y2 minus y1. So second calc y2 minus y1 And with respect to x, that says the answer is, I believe, 12. It is 12, and you get 12 plus 12. They are the same area, or 24 as your final answer. So the yellow was 12, the blue was 12, and they added together to be 24. So nice work. All right. Why don't you try vertical slicing method of this next one? Maybe I'll set you up like usual. No calculator this time. Dun dun dun. Notice we have an enclosed region. The first function, f of x, I'll do it in red, is the square root of x. It looks something like this. There is your square root of x, or actually I'm going to call it f of x, or y1. Oh wait, I'm not allowed to use a calculator, so I might as well just leave it as f of x. Then in blue, we have y equals 0. So that's just a nice horizontal line at y equals 0, right? Where y is always 0, but x is constantly changing. So that is y equals 0. Let's call that y1. And then in green, I would have y equals x minus 2. So y equals x minus 2, it goes up 1 over 1. It looks a little something like this. And I will call that graph y2 just so you know which ones I'm talking about. So I will call this one y1 and this one y2. Now we want to find that highlighted area, but what do you notice when you do your vertical slicing, what we've been doing? You will do that, but notice at one point, there's a time where this thing has the red ones on top and the blue ones on the bottom, and then the red ones on top and the green ones on the bottom. Two different things. So why don't you set up the integral and we'll see if you're right. All right, nice work. Did you find the two intersecting points? Well, the first one was at the point 2, 0, right here. How did I find that? I found, right, the intersecting point. I just set the two equations that it was going to cross at, y1 and y2 equal to each other, and I solved it. And I got the answer was 2. Then I found the second intersecting point, which I never labeled because I didn't know it at the time. It looks like 4 comma something. I don't know, when x is 4, right? I could probably plug in a 4. I think it's 4, 2. And the way I got that was right here when I did intersecting point number 2. Now, a little tricky thing happened there. When I set them equal to each other, the first step I had to do is square both sides. The weird part of when you're squaring both sides is you're taking there's a chance that you're going to get an extraneous answer, and you see I did. When you're taking something that's linear and you square it, something that had one answer, and now you're giving it 2 answers all of a sudden by squaring it, there's a chance that one of your answers are going to be gross. And it did turn out that I got answers were 4 and 1, and the 1 was extraneous, so I tossed that out. All right, now can we set up our integrals? Let's see. Go ahead, set them up, and I'll see if we're right. All right, there's my integral setup. Is that what you got? Let's see, from 0 to 2, it's the red minus the blue, and since the blue was 0, I didn't bother putting it. And then the integral, we have to add to it the integral from 2 to 4, which was the red minus the green. Now, be super careful right there. There's a chance that you're going to have to hope that your computer doesn't crash. Now, be super careful there, because you're going to have the one integral, right? But this one, you would get root x minus x plus 2. I bet a lot of people will miss that plus 2. All right, so there's my integral. Now let's evaluate it. And once we're done evaluating, we will see if you're right. And you will have done this whole problem pretty much on your own. So, be right back. All right, that turned out a little trickier than I thought, but as I integrated this, you can see I went up a power and divided, or multiplied by the reciprocal, and then evaluate from 2 to 0. Then this guy had to do the same thing. Luckily, I just kind of copied it. And then I went up a power and divided by 2, and then I went up a power divided by 1 and evaluated that. Then I cried because I had to plug a 2 in, but it wasn't really that bad, right? It was the cube root. First I had to cube it, which was 8, and then square root it, which would be square root of 8, or 2 root 2. And then I did 2 root 2 times 2/3 is 4 root 2 over 3. Cried because I was like, that's never going to go away probably. And then I plugged in 0, which gave me 0, so I didn't bother subtracting. Then over here I had to plug in 4, and so again I plug in a 4. I square rooted it, which was 2, and then cubed it, which was 8. And 8 times 2/3 is 16/3. And then I plugged the 4 in here, and I got 16 times a half, which is -8. And then 2 times 4, which was 8. So good news, those two things are going to cancel. Then over here I plugged in the 2, and again I got the square root of 2 cubed, so that would be 2 root 2 times 2/3, which was 4 root 2 over 3, which, good news, notice that here it's positive and here it's going to be negative, so they canceled out, and that made me a little happier. Continuing on to plug in the 2, I squared, I get 4, and half of 4 is -2, and then right here, plugging in the 2, I get 4. And then I said, sweet, now I just have 16/3, and then I knew that this was 2, but it's going to be minus, so I put -2, and 2 is 6/3, and I got 10/3, and I got my answer. Holy macaroni, nice work. Whew. All right. All right, now let's try number 6, and let's blow your mind. Now we're going to do a horizontal slice. Ugh, I didn't want to do that, right? And so I want to do a horizontal slice. And what that means is your computer will crash. And that means that now that you have this horizontal slice, then you no longer have the width of your rectangle is dx, it's now dy, and you're kind of moving your brain, everything the other way. We're going to talk about in terms of y. So instead of going, you know, from top to bottom, we're going to go right to left, because look at the function that we called y2 is always going to be the right side, and the function we called f of x is always going to be the left side. So therefore this would be really nice. Now the only weird part is I said I needed f of x and y2. So y2 was x minus 2. Now these equations are always nice because they said y equals or f of x equals. If you're going to do it the other way, you need the equations to say x equals. So that's not a big deal. This would say y2, I should probably just call it y, but I would have added the 2 over, and that would be our y2 equation, right? Or our right equation. And our other equation was y equals the square root of x. Well, we would square both sides. And so if I square both sides, I'd get y squared equals x. And now I have the equation that I need for the second one. Now again, probably really don't need the negative one part of the y's, but we don't care because they're going to get cleared up in the squaring. So now when I want to do this, our head is totally spun around, and what you have is you have the integral. Now look, I'm going in the integral in the y direction, so we're going to be going from the 0 all the way up to what intersection point I found was y was 2, so we're going to go from 0 to 2, and we're going to take the right equation, which we said was y plus 2, minus the left equation, which we said was y squared, and that is dy. And now I can integrate that bad boy. So let's see, that doesn't look too bad. In fact, I didn't even need the parentheses there. So let's go up a power and divide. We'll have 1/2 of y plus y squared, plus go up a power and divide, so 2y. And then minus, go up a power, and have 1/3 y cubed evaluated from 0 to 2. And we know the answer better be 10/3 because we just did it, right? So let's make sure. If I plug in the 2, I get 4 over 2, which is 4 times a half, which is 2. I get plus 2 times 2 is 4. And then I get 8 times a third is minus 8/3. And then if I plug in 0, I get nothing. So that's awesome. So all I now have to figure out is what's 2 plus 4. That's 6 minus 8/3. And if 6 is 18/3 and minus 8/3 is 10/3. And there you have horizontal slicing. And you might feel like, whoa, that was a lot prettier, but realize what we did. Right? We did have to make the equation say x equals. We did have to go right minus left. So there were things we had to worry about. That's it. Stay happy, and I'll see you tomorrow.